Hello, my name is Jinny Chung, and I'm an undergraduate student at the University of Pennsylvania, planning to major in physics and neuroscience. This summer, I had the wonderful opportunity to work with Dr. VC's lab through PURM and explore the effects of chronic sleep disruption on hippocampal tau, as well as study the Locus Coeruleus projections in 4 brain areas. Through previous research, we know that a significant risk factor of Alzheimer's disease is sleep disruption in the form of insufficient sleep and sleep fragmentation. Now, we're not fully sure of which mechanisms underlie the relationship between sleep disruption and Alzheimer's disease. But we know that both sleep loss and early Alzheimer's disease show increased amyloid beta deposits and tau phosphorylation in the hippocampus, as well as the loss of locus coeruleus neurons. We also know that neurofibrillary tangles result from hyperphosphorylated tau and that accumulates in very specific brain regions that are involved with memory. The mice that I worked with are humanized amyloid precursor protein noctin mice, referred to as HAPG mice. And you might be wondering why HAPG? Well, they're a very good integrated animal model that allows us to explore the effects of sleep loss on human APP and the effects of tau. My project aims to characterize the impact of humanized A-beta on tau phosphorylation in the hippocampus in locus coeruleus projections into 4 brain areas. The mice that I used for my study had undergone 16 weeks of sleep fragmentation. They were a year old at the start of the sleep fragmentation and were perfused at 19 months old. Mice were randomized to rested or sleep fragmented conditions, and the sleep disruption was set up so that mice were awake for 10 seconds once per minute, 24 hours a day. Once we perfused the mice, we performed immunohistochemistry on the cryopreserved brains, and I used AT8 and AT180 and NET plus AAP tau for staining the CA1 region of the hippocampus. The percentage of the stains were then calculated using ImageJ, a open source image analyzing software, and the projections were measured and categorized through a program that was coded using Python. Finally, my results showed that CSD results in early phosphorylation of tau in CA1, but did not increase AAP cleaved tau, which suggests that phosphorylated tau cannot be attributed to CA1 AAP activation. Furthermore, there were no significant influences between chronic sleep disruption and NET percentage area. In the future, we also hope to determine how significant APP is in the locus coeruleus relating to sleep loss, as well as hopefully comparing mouse and human results in tau, as we can expect to see some differences in tau phosphorylation and tau processing. Thank you so much to PURM for funding my study and the VC lab for such an amazing summer research experience. Thank you.